we talked about the ideal gas law, and that really is only one law. But if we want to talk about all the separate laws, one of them is called Charles' law, and it states that if the pressure remains constant, then it says what's going to happen about the volume and the temperature. So what I would do to sort of derive Charles' law is I would still remember that between 0.1 and 0.2 of two different fluids, they both have exhibit the ideal gas law, which is PV equals nRT, PV equals nRT, subset 1, and at position 2, it's subset 2. But in this case, the amount of a substance N1 equals N2, which is just, we can call N. The type of substance R1 equals R2, which we can just call R. And in the terms of Charles' law, which we're looking for, it says that the pressure 1 equals pressure 2, which we can just call P at this point. So then I can solve for N and NR over, I can solve for NR, which would be P1 V1 over T1, which would be the same as P2 V2 over T2 because NR is the same in both positions 1 and 2 of this fluid flow. I also said that P1 equals P2, so I can rename that as P V1 over T1 equals P V2 over T2. But since P is the same on each side of that equation, it crosses out, which gives me V1 over T1 equals V2 over T2. And lots of people like to write it in this format, and I can rearrange this format just by dividing by V2 on one side. V1 over V2 is going to be, and I'll multiply each side by T1 over T2. So we have taken the ideal gas law at 1 and 2 and illustrated that when pressure holds constant, we get Charles' law. And we can do the same thing for Gay-Lussac's law. And in this one, Gay-Lussac said that if the volume of a given gas remains constant, then we're going to get this relationship between pressure and temperature. So let's let V1 equal V2 in two positions from 1 to 2. Look at the ideal gas law that states PV equals nRT for 1 and PV equals nRT for position 2 where this gas is flowing, but it's the same gas. Therefore, the amount at 1 equals the amount at 2, which is the amount. The type of substance equals 1, type is the same type of substance equals 2. We can just call that the substance. And we are also letting V1 equals, we're also letting V1 equals V2, so we can just call that V. So if we substitute this in here, we rearrange for NR, then NR is going to be equal to P1 V1 over T1, which equals P2 V2 over T2. And the volumes are the same. We're going to let the volumes be the same. Therefore, this is P1V over T1 is equal to P2V over T2. I have two volumes here. They're exactly the same. They're on both sides of the equation, so I can cross them out. So I'm left with P1 over T1 equals P2 over T2. I can rearrange that in the format that people like here by dividing by P2 and multiplying by T1 on each side, so that you can clearly see that when pressure changes from 1 to 2, it's got exactly the same change in ratio of temperature. And people like to call that Gay-Lussac's law.